This lesson is for Advanced Algebra, Lesson 3.1, on the graph of y equals mx plus b, and on constant change. The equation y equals mx plus b is called the slope-intercept equation. Unfortunately, it's not called the slope-y-intercept equation, because those are the two things that it contains. The m in the equation, the number right next to x, is called the slope. Remember that the slope, if it's a positive slope, will be graphed as a line going up from left to right. The slope, if it's negative, will be the graph of a line going down from left to right. The x is the independent variable, and the y is the dependent variable. The b value, the number that doesn't have a variable next to it, is the y-intercept. Remember that an intercept is simply where something crosses something else, and so the y-intercept is where the graph will cross the y-axis. So that coordinate is actually the coordinate 0b, 0 for x, and then whatever that value is. The book refers to the b value, in some cases, as the initial condition. So if students see that phrasing, they should know that that piece of information is simply where the graph will start. When graphing the slope-intercept equation, know that you can always make a table, not just for the slope-intercept equation, but for any equation. When you make a table, you simply choose some values for x, plug those values into the equation, and then solve for y. The nice thing about the slope-intercept equation, however, is you don't need to make a table. You can simply graph it from the b value, and then using the slope to find additional coordinates. So you start with the b value and place it on the y-axis, and then use the slope, which is up here. A positive number on the top will mean you'll move upwards. A negative number on the top means you'll move downwards. On the bottom, if you have a positive number, you'll move to the right, which is probably what will happen the most often. On the off chance that you have a negative number on the bottom, you will move left. So let's demonstrate that with a few examples. So on this first graph we have y equals 2x minus 4. The b value is where we want to start, and that is the number that doesn't have the x next to it. So I'm simply going to put a dot at negative 4. So I start at 0, 0, and I count down 4. Using the other number, the m, or the number next to x, the slope, the top number is the rise, the bottom number is the run. So the top number tells me which way I'm going to move, either up or down. If it's positive, I'm going to move up. From this dot, I'm going to count up 2 and to the right 1. And then I'm going to continue to do that until I have a minimum of 3 points. Up 2, over 1. Then we just connect those with a straight line. If students have a straight edge available, like the edge of their calculator or their cell phone, they are encouraged to use that to make a nice straight line. When you're working with a problem and it has a negative in front of it, especially if it's a negative fraction, students should choose to put the negative either with the top or with the bottom, but not with both. If you put it with both, now all of a sudden you're doing negative divided by negative, which is positive. This has a negative slope, so we know that it's going to go down from left to right. Start with the b value first. On the y-axis, go up to 2 and put a dot. From here, the top number is negative 2, so I'm going to count down 2. The bottom number is positive, so I'm going to go to the right 3. Down 2, right 3. And when I connect with a straight line, it's clear to see that the line is indeed going down from left to right. For our third example, there's a piece missing. We have a slope, the number next to x, but the other number is simply a 0. So that means the b value, the y-intercept, is going to be at the point 0, 0. From here, I'm going to do a rise of 4 and a run of 1. So I'm going to go up 4 and over 1. Up 4 again and over 1. Clearly this line is the steepest line that I've graphed so far, and it's simply because the slope is the largest slope that I've done. On the last one, it's very easy for students to get tricked here. They believe that since this number is next to x, that this number is the slope. However, this equation is not in the correct format. It doesn't have y alone with everything else on the other side like the other three examples have. So it's very important for students to recognize what format their equation is in. If the equation is in another form, they simply need to solve for y. So we're going to go ahead and do that on this question. To try to get the y alone, we need to move the 4 and the 3x. The 3x can move as one unit. It is being added currently, so to get rid of it, we're going to subtract. Make sure that you do it on both sides. Make sure that you only do it once on both sides. A lot of times students will put the minus 3x here as well, and they don't need to. The 3x's will cancel, the 4y drops down, and then students have two options here. They can rewrite what they have, 12 minus 3x, or to keep things in the proper order, they can put the negative 3x first and then the 12 after, keeping in mind that the 3 is negative but the 12 is not. Now to get the y alone, we would want to divide by 4. Since we are dividing by 4, that means everything gets divided by 4. So we do need to divide the 12 and the 3. You can either do it together with one big fraction bar or you can do it separately. I would encourage you to do it separately because the m and the b are separate numbers. The 4's here will cancel. Here we get a 3, and then we can simply leave the slope as a fraction. So we'll do the same thing for this version. Notice that we get the same answer, but I like the second one here because it's in mx plus b form, which is what I'm used to. So now when I graph it, I'm going to put the y-intercept at 3, and the slope is negative 3 over 4, so I'm going to count down 3 and to the right 4. And then we would just connect those as well. We would do it again to get another point and then connect. So just another reminder here, when equations are not solved for y, it's important for students to go ahead and do that and then graph it using the techniques we've been using. Once in a while, a question will ask students to find an x-intercept. Remember that this equation, since it's solved for y, has an m, a slope, and a b, which is the y-intercept. So to find the x-intercept, we will plug in 0 for y. If we do that, we'll get a value for x, and that means that coordinate will be on the y-axis. Some students think that they can graph the equation to identify where the x-intercept is, and while that is true, sometimes that coordinate can still be a little bit difficult to find. For example, if you graph your line and it ends up being graphed like that, it may be difficult to figure out if that is indeed 0.5 or maybe 0.4 or 0.6. So when it doesn't cross at a nice whole number, sometimes that x-intercept can be difficult to identify. If you plug in 0 for y, you'll always be able to get an exact value for your answer. So if we plug in 0 for y and now solve for x, we would add 4 to both sides, and then we would divide by 2, so x is 2. So that means our x-intercept now is the coordinate 2, 0. We plugged in 0 for y and we got an answer of 2 for x. Some students might be thinking by now, what do I need the slope-intercept equation for other than to graph easily? A lot of real-life problems involve a slope and an intercept. So let's take a look at this particular example. A water tank holds 100 cubic inches of water, but a slow leak develops and it loses a half a cubic water every day. Write an equation to illustrate this situation. Remember that in the mx plus b equation, there are two pieces. There is the b value, also called the initial condition, or the starting number. It's also basically just a straight up number. It's just a factual piece of information. It is simply a number. If you read this problem, there is one number given to us that is a statement of fact. There are 100 cubic inches of water. That's also our starting value. That's how much the tank will hold. The other number we're given is that it loses half a cubic inch of water every day. So that is representative of the slope. The slope is also called the constant difference or the constant change. Something that constantly happens or repeatedly happens is your slope value. So if it loses on a regular basis a half a cubic inch of water, we know that that is the m, or the slope. So in a lot of situations you'll have an initial condition given and then a repeated value which represents your slope. So there's our equation. Since it's losing water, we know that that number should be negative. And then it starts with 100. So there's our equation in slope-intercept form. Lastly, there are some vocabulary words that students need to make note of. In the homework, there may be mention of things that are considered coefficients. That should be a review item for students, but I just wanted to quickly mention it, that a coefficient is the number in front of a variable. And so I think it is mentioned in this lesson in particular because the slope is typically the coefficient on the x value. So typically the m is considered a coefficient. Keep in mind that all variables have a coefficient, even if it's not listed. If you look at the equation up above here, there is no coefficient listed next to the y, but we know that there is at least one y sitting there, so that one has a coefficient of 1. The x here has a coefficient of -1/2, because that's the number in front of the variable. Constant increase and decrease is another way to describe slope of a line. Keep in mind that if it's increased, that means it will be a positive slope. And if it is a constant decrease, that means it is a negative slope. So again, that refers back to our water tank problem where we were losing constantly a half an inch of water. So that is a constant decrease situation, which is why we made that number a negative. In the warm-up to this lesson in class, students practiced a little bit with horizontal, vertical, and parallel lines. And the conclusions that we drew from that warm-up resulted in the fact that horizontal lines have 0 slope, and that vertical lines have no slope. And finally, that parallel lines have the same slope. It's very important that students get those ideas memorized because they will come up frequently in Chapter 3 and throughout the school year. Finally, we need to give equations for these. If we use y equals mx plus b, and we know that the slope is 0, 0 times x is 0, giving us simply y equals b. So when you're trying to find an equation for a horizontal line, find where it crosses the y-axis, and then just say y equals that number. Vertical lines don't have any slope, which is much different from saying that the slope is the value 0. So horizontal lines have slope, and the value of the slope is 0, but vertical lines don't have slope at all. So we're not going to use the mx plus b equation to describe it. A vertical line is simply going to cross through the x-axis at one particular spot. So we simply say x equals a number. And I'll just leave an empty box to represent that number. And then parallel lines have the same slope. That actually comes from a theorem which is in your textbook called the parallel lines and slopes theorem. Notice that this statement is a biconditional because it includes the phrase if and only if. If something is a biconditional, that means it works in two directions. Bi means two. So if you read this statement forwards, you get this statement. Two non-vertical lines are parallel if they have the same slope. You can also read the sentence backwards and get an additional piece of information. If two lines have the same slope, then they are parallel. Since we can put those two statements together, we simply put it together with this phrase if and only if in the middle, and that represents that this sentence can be read in both directions. So it's called the parallel lines and slopes theorem. So students need to keep that in mind, that if they know they're parallel, they can conclude that they will have the same slope. If they determine that two lines have the same slope, then they can conclude that those lines are indeed parallel.